Alright everybody, I hope I'm audible right now. So let's just simply get started from here on. So the main goal is gonna be the GenAI part. That is something we are gonna be covering right here. And let's see what all we can accomplish. So I have one of the eraser, what is this called? Canvas link. So I'm just simply gonna be going through it all. And this is how we'll be just simply going through the stuff related to GenAI. So first of all, we have to go through all this stuff, and once we are done with this, then we'll just simply continue from here on. So when it comes to introduction to the AI world, so I'm gonna be starting it from scratch, and this is sort of a revision for me. So when it comes to GenAI, so ultimately there is something called GPT. So the full form of GPT is generative pre-trained transformer. So generative in the sense it is generative in the sense it generates now I'm stuck just a sec. Generative pre-trained transformer. So generate pre-trained transformer, that simply means it is used for generating the stuff, and it is actually pre-trained on the data, and at the end of the day this is just a transformer. And research Python, that is fine. Application developers, real world business, that is also fine. I'm just simply going through the stuff that needs to be revised, and then we'll go through the stuff. And meanwhile, let's talk to the AI as well. Tell me about Gen AI. So here we are, generative AI. Coming back to this, so generative AI is a branch of artificial intelligence that creates new content instead of simply analyzing or classifying the existing data. So ultimately, it creates the new content. That simply means it generates that. So GPT, sort of generative pre-trained transformer. Given prompt, it can generate text, images, music, videos, software, code, and more by learning patterns from large accounts of training data. How GenAI works: at a high level, the process is training. A model learns statistical patterns from large data sets. Prompting: a user provides an instruction, question, or example. Generation: the model predicts the most likely output based on what it learned. And the thing is that once the user actually provides something, it first of all tokenizes that. After tokenizing, it does something, I forgot that, we'll go through that. And then refinement: the output can be edited or regenerated until it meets user needs. Common types of GenAI: text generation, writing emails, articles, summaries, or answering questions. Image generation, creating artwork, logos, illustrations, or photos, realistic images. Code generation, audio generation, video generation. Real world applications, it just simply keeps going on. Benefits, limitations: GenAI versus traditional AI, classifies or predicts, creates new content, detects fraud, writes reports, and so on and so forth. Recommends projects, recognizes images, forecasts the demand. It just simply sort of creates the things on its own. Popular GenAI are these: ChatGPT, Google Gemini, Microsoft Copilot, Claude, DALL-E image generation, DALL-E, whatever it is called. And then we have Midjourney over here. Okay, great stuff. Going through this one over here, we have GPT, and apart from this particular thing, LLM talk, that is fine. Ultimately, this is the thing that we were talking about. So if there is any input, so when we just simply give the input to the any AI, so first of all the input is tokenizes, then that's encoded. So first of all tokenizing process happens. After that it is embedded, so vector embedding happens. So vector embedding in the sense, in 3D vector, it's the data is sort of stored at the right place and that is sort of linked. And semantic meaning in the sense it just simply talks to each other, if I'm not wrong. Vector embedding in the sense it just simply gets saved in the vector DB. We will go through it. Semantic meaning means it just simply tries to get the right meaning out of it. Positional encoding means the vectors or the data just simply, the tokens, they talk to each other and they just simply make sure that they are positional the way they've been saved, that is right. Self attention sort of related to that. Again, I cannot be 100% sure about this, so we will talk to the AI and go through this stuff. And apart from this particular thing, when we give the input, so first of all the input is actually tokenized, and after that embedding happens. After embedding, positional encoding happens, and things just simply keep going on. So we will have to go through this part and understand more about it. Temperature means it just simply sort of adds variety. So if the temperature is lesser, so you will be getting the exact output, or the, like output to the point. And if it is more, then you will get some added result at that on top of the remaining one. So kind of the response is gonna be varied. And apart from this particular thing, we have data algorithm, decoding AI jargons. Okay, that's not this. In the world of synthetic, let's generate some human data, that is okay. And GitHub, this is the one that we have to just simply go through. And these are the things. So let me, because I'm gonna be talking to the AI regarding all these things, so the AI has to, this is the first photo, and the another one is gonna be this. So the AI actually has to explain each and everything in quite detail. So let me just simply keep it here. You have to explain it in detail, and keep it simple. I mean, whether it keeps it simple or not, that doesn't really matter. So let's just simply continue with this. Absolutely, these are the core concepts behind modern large. Just alright, ignore the like voice sound around me. These are the core concepts behind modern large language models, LLMs, large language models like ChatGPT, Gemini, Claude, LLM, Llama, what is this called, DeepSeek, etc. If you understand these concepts, you will understand how ChatGPT actually works. I'll explain them in the order they happen inside a transformer. Big picture. So now the question is, what is a transformer? First of all, this thing. So let me now duplicate this so that I can just simply talk to this on the go, because at the end of the day we have to go through everything. What is a transformer? A transformer is a neural network architecture introduced in 2017 paper. Attention, all you need. It is a foundation of nearly all modern LLMs, including GPT, Gemini, Claude, LLM, DeepSeek, Mistral. The key innovation of the transformer is that it uses attention instead of processing words one by one, like older models, RNNs or whatever this. This allows you to understand relationship between words much more efficiently. Think of transformer as a smart reader. So imagine you are reading this sentence: the animal didn't cross the road because it was tired. So when you read the word it, your brain immediately knows it refers to animal, not road. A transformer does something similar. Instead of reading one word at a time and forgetting the past, it looks at all relevant words simultaneously and decides which ones are important. Why it was invented, we'll continue from here on, but let's, before even that, let's read this part. So transformer is clear. This is the neural sort of a neural network of the data. Ultimately, that's what was mentioned here, right? So it is sort of a smart reader, and it is a neural network architecture of the data for sure. So neural network architecture, where the data is just simply linked, or the vectors are linked, or the whichever way the data is there, that is linked with the right semantic meaning. We'll go to that. Big picture: suppose you type the cat sat on, then the model's job is to predict the next word. The complete pipeline looks like this. We give the sentence, sentence gets tokenized, then it gets embedded, then positional encoding happens, then transformer layers, self attention, multi-head attention, feed forward, add normalization, then linear layer happens, soft max happens, probability of every word, and the next word is generated. So this is the overall the flow, the the flow that it just simply goes with. So let me just simply have this overall flow in here, and once we have this flow over here, so it's time to go through it all. So coming back to this tokenization, first of all we give the sentence, that is pretty simple. Just after we give the sentence, so the next thing is the tokenization that actually happens over here. So when it comes to tokenization, so first the model cannot read English, it only understands numbers. So your sentence, the cat sat on the mat, is broken into small pieces called tokens. Example, the is converted to this. So ultimately they are converted into tokens. The sentence becomes sort of like this. These numbers are called token IDs, and we can even see them in action. So tokenizer, tokenizer, I think there's one by, I mean we can just simply click on any one of them, and hopefully, yeah, we can just simply click on any one of them. The cat sat on the mat. So the cat sat on the mat, this is the tokenizer. Tokens IDs are these. So we have the tokens IDs, we have the text. There are 6 tokens, there are 22 characters. We can just simply have the example as well, and this is the overall example looks like. And the way the tokens are actually generated, that just simply changes as per the models as well. Yeah, because in one model this whole Unicode is gets converted into token, and in another one this Unicode is further uh, divided. So this is how it just simply goes on. Anyway, we know how it works. Like there are many tokenizers over here. This is by Hugging Face, and I think the same thing can be done over here. Tokenizer and tokens counter GPT, Cloud Gemini and all. It just simply keeps going on. Yeah, so overall there can be many tokenizers, and there was one for by Vercel side. I can't really see it here, but okay, they do exist. Coming back to this, these numbers are called token IDs, and it's good to do many things at the same time. Many things in the sense it's good to do it in action. We will go through it anyway. Then why not characters? Instead of ACT, the model stores cat because it learns faster. CAT, it stores cat. Okay, that's fine. Sometimes words are split, unbelievable, so maybe unbelievable, just something like this. Vocabulary size, the model keeps dictionary that just simply references to the words. This dictionary is called vocabulary. Vocabulary size means how many unique tokens exist. GPT-4 may have around 100,000 plus tokens, so 100,000, so that simply means 10 to the power 5, or ultimately around a million. Okay, embeddings, numbers like 3 with this don't contain meaning, so each token is converted into a vector. So instead of 3 to 3 4 5, it becomes this, so they are actually converted into vectors. This is called an embedding. So each word becomes a point in a huge mathematical space. So there is a 3D vector, and the words tokens, like tokens IDs, they are just simply saved in there. Example, king might become this, and while queen is gonna be nearby, because similar words should have similar vectors. So king, queen, prince, princess, they are gonna be close, and king, laptop, pizza, they are gonna be far apart. Model learns this automatically. So ultimately the tokens are embedded in the vector DB, and they are saved. If they are similar, then they are saved kind of they're connected, otherwise they're far from each other. Semantic meaning. Semantic means actual meaning. So car, vehicle, automobile have similar meaning. Their vectors become close together. So if they are sort of same, so their vectors are gonna be close to each other. If they are not, their vectors are not gonna be close to each other. Again, happy, joyful, excited. Again, nearby vectors. This is why embedding works. Positional encoding. Transformers don't know the order. So imagine the sentence dog bites man or man bites dog. The words are the same. Without positions, both look identical. So position information is added. Word dog position 0. Word bites position 1. Word man position 2. So the embedding is modified. Final vector is gonna be embedding plus positional encoding. That simply means when we have a vector db, so over there we have the embedded data plus we have the right order, so that right position as well with the embedding. Now the model knows dog came first. Transformer. This is the brain. A transformer contains many identical layers. Your diagram shows nx, that means repeat n times. GPT-3 uses 96 layers. Llama uses dozens of layers as well. Each layer learns more complex relationship. Inside one transformer layer, each layer has self-attention, add norm, feed forward, add norm. Let's understand them. So ultimately, there's a lot to just simply go through. But at the end of the day, we have a sentence that gets tokenized into tokens, and we get the token IDs that gets embedded into the embedded DB, like vector database. Embedding in the sense that just simply saved, and if that if the words are close to each other, they are gonna the token IDs are gonna be close to each other, and they'll be saved in the DB closed. And if they are different ones, so their token IDs are gonna be different, and ultimately when they are embedded into the vector DB, it doesn't really matter what the token ID is. Once they are embedded into the vector DB, they'll be embedded far from each other if the meaning is different, and if the meaning is sort of similar, so they are gonna be close to each other. Then we have positional encoding, because we never know the right order. So the man, the cat, like the man bites dog or the dog bites man, ultimately the vector is gonna be the same, because ultimately when we convert that, so the vector is going to be the same. So now to know the right order, we just simply save the positional encoding with the embeddings in the vector DB, and then we have these. So we've gone through it. Inputs, embedding, positional encoding, all these things, these steps we've gone through. Then multi-head attention, add and normalization, feed forward, and then add and normalization, and then again the same thing happens, that is repeated. Then linear and softmax, and then it just simply keeps going on. So coming back to this self-attention, so just after that, what do we have? We have multi-head attention, or we can call self-attention. So let's go through that. This is the most important idea. Suppose we have the animal didn't cross the road because it was tired. What is this? It refers to road, animal, human, no animal, humans, no animal. Self-attention lets the model figure this out. Okay, each word looks at every other word. So self-attention means each word will have a look, or will know about the other word. So the animal didn't cross road because it was tired. When processing it, attention may look like the 0%, animal 65%, road 5%, tired. So the model learns it means animal. Okay, so ultimately when each word knows about the other, when they have the attention of the other word, so they are given sort of a probability, and on the basis of that thing, the model knows that okay, it may reference to this and all, without being explicitly programmed. Query key value, every word produces query key and the value. So query, the key and the value. Okay, the query key and value, fine. Three vectors, think of them like a query. I'm looking for related words. So suppose we have it, the key is what I represent. So suppose I represent it and value my information, then the model computes query multiplied by key. This gives attention score. This is the query, this is the key, this gives the attention score. Softmax. So ultimately, keeping it simple, what actually happens that when it comes to self attention, that simply means each word knows or have the attention of the other word. It knows about the other word, and on the basis of that thing, those words uh, know that okay, which thing refers to what, to be, to have it simple. Then softmax, suppose the attention scores are animal 8, road 3 and t3, 3 1. These are not probabilities. Softmax converts them into the probabilities, and now all numbers are between 0 and 1. Sum to 1. This is much easier to use. Percentage, that's fine. So this is called softmax, just simply converts them into percentage. This is as simple as that. Multi-head attention. Why only one attention? One attention may learn grammar, another meaning, another pronouns, another verb, tense. So the model creates many attention heads. So head 1 subject, head 2 object, head 3 time, head 4 meaning, all are combined. This gives richer understanding. So it's like when you see something from different perspective, you get different understanding. So if we just have a look at a sentence from different perspectives, so we have ultimately overall the right meaning, and hence we are gonna be having multi-head attention. Feed forward network. Attention mixes information between tokens. Then feed forward network. So the attention mixes information between tokens. Then every token is independently passes through a small neural network. Attention mixes information between tokens. Okay, that's fine. So there can be many tokens and the information can be mixed. Then every token is independently passes through a small neural network. Token linear, these relu gelu forget about this, linear. This lets the model transform and refine the information it gathered from attention. So the attention, from the attention we got the information, and after that that just went through ultimately neural network, and the meaning even got refined. Add and normalization. Every transformer block has add and normalization. Add residual connection. Instead of replacing the old information, output input plus new information. So whatever the output was in the input, output is gonna be equals to input plus the new information. So input is still gonna be there. This helps preserve the information and allows the gradients to flow more easily during training, making very deep models train successfully. Layer normalization. After adding addition values can become too large or too small. Layer normalization rescales them to stable range, improving training scalability. Encoder, we've quite gone through many things. So we have input, we embed the data. Input, after even inputs, we tokenize the data. Once the data is tokenized, that is embedded in the DB, and after that we even save the positional, we add the positional encoding in the so that we know what's the right order. And after that we have self attention and multi-head attention. In this way, the data, the words they just know about, they have the attention or information about the other one. So this way they can just simply get the derive the right meaning, and they would know which word references to which another, I mean which word references to which another word. And then add in normalization. Adding means when we pass the input and the new information is just simply added, so we just simply get input plus the response. Normalization means that is just simply normalized, so the data can be less, or, I mean the data can be a little or a lot, and so it just simply normalized. Feed forward is something that I've again forget about this, like it's just about knowing having the info about it. Feed forward is something that went to like I've forgotten again, so let me just simply have a look at that. And normalization is only we've gone through. Then we have the encoder, so that is the same, right? Feed forward, encoder. Feed forward, we only have it here. Okay, we'll go through it. So we have encoder. The encoder reads the entire input and builds a contextual representation. Every word can attend to every other word. It's mainly used in tasks like translation, understanding of the source sentence, classification, summarization, understanding of the document, English sentence, encoder and meaning of the representation, decoder. The decoder generates the text one token at a time. So encoder just simply encodes the English sentence in the meaning representation. Decoder is gonna be just simply decoding that. So it uses self attention, meaning it can only see the words already generated. It uses marked self attention, meaning it can only see the words already generated. And that's right. The cat sat on the mat. It cannot peek ahead. This is how auto or regressive text generation works. ChatGPT and GPT models are decoder only transformers. So ultimately, when we send something, they get the data, they just simply decode that. They do not use the encoder shown in the original transform diagram. Encoder, okay, that's fine. Mass detention. Suppose we are generating the cat set. When the predictions when the prediction set, the model can see the when predicting the set. Just a sec, yeah, hopefully I haven't clicked on the wrong one. So when predicting set, the model can see the cat. It cannot see the future words like on the mat. This is enforced with the casual mask linear layer. After the last transform layer, each token has final hidden vector. A linear layer converts this vector into one score called logic for every token in the vocabulary. If the vocabulary has 10,000 plus 100,000 tokens, the output is gonna be 100,000 logits. So cat, dog, mat, tree, whatever this is. Softmax final output. So Nelia does what? After the last transform layer, each token has final hidden vector. So ultimately, a linear layer converts this vector into one score called logit. So for every token in the vocabulary, so if it has this, then 12 by this is sort of a log. Based on these probabilities, the model is gonna be just simply choosing the values, and the temperature controls how random the output is. Low temperature 0.2 means might this, so very deterministic, and high temperature means it can be somewhere here and there, more creative and diverse. 0 to precise, factual, repeatable. 0.7 to unbalanced. 1.2 creative, knowledge cutoff. LLMs are trained on data collected up to certain point in time. If a model has knowledge cutoff during this, then without external tools, it doesn't know events that happened after that date. Okay. Models can overcome this limitation by using web search or retrieval system to access newer information, putting everything together. User tokenization, token IDs. After that, we get we embed the data. We have the positional encoding. We have the transform layer repeated n times. Okay, that just simply keeps going on. Self attention, it knows about each other. Feed forward, don't know what it does. Add normalization, and norm is simple. It normalizes the data and it just simply adds the input as well in there. Linear layer logics for every vocabulary token, so it just simply creates the logic. Softmax just simply converts them into probabilities, and temperature adjusts the probability distribution. Next token is selected and then appended, so repeat until it actually completes. So it just simply keeps going on and on. Feed forward is something I missed, so let me just simply have a look at this. That is feed forward. Here it is. Attention mixes information between tokens, then every token is independently passes through a small neural network. So feed forward network, so like passing the tokens independently through a neural network. That is what the feed forward is. So this is the feed forward network ultimately. So network is actually gonna tell me that it is being passed the feed forward network. So it is passed through neural network. So ultimately, every token independently passes through the small neural network. Okay, and if possible, I'm gonna be just simply saving it in here. Okay, so overall we have gone through the stuff. Okay, what's the next thing that we can do? Mm, understanding the diagram you shared. The second image is the original transformer architecture from 2017 paper. Attention all, you need a left side encoder stack reads and understands the input, right side decoder, though the left side actually encodes, right side decodes, decoder stack generates the output, that is right. Input embedding, output embedding converts token IDs into vectors. Positional encoding adds word order information. Multi-head attention learns relationship between words from different perspectives. Masked multi-head attention prevents the decoder from looking at future tokens. Masked multi-head attention. Masked. This is the one. So masked multi-head attention. So what it does actually here, that is prevents the decoder from looking at the future tokens. So it just simply decodes. It doesn't really care about the future tokens. That is okay. Feed forward refines each token's representation. Feed forward refines each token's representation just by passing through the neural network. Add a normalization, residuals. I don't know how to pronounce it, but hopefully residuals connection plus layer normalization for the stable training. Linear softmax converts the final hidden state into probabilities over the vocabulary. So this is something interesting part. So we are gonna be having it in here. For GPT style models like ChatGPT, only the decoder portion is used, while models like BERT use only the encoder. Decoder models such as T5 use both. This distinction explains why GPT excels at text generation while BERT excels at understanding the text. So the first one is actually used for understanding, and second one is for the generation. Anyway, just this much info is more than enough as of right now. And even we know about the transformer, exactly what the transformer is. So ultimately it is just a neural network of the data. So a transformer is a neural network architecture that understands, it is a neural network architecture, as simple as that, that understands and generates language by allowing every token in sequence to attend to every other relevant token, transforming their representation through repeated attention and feed forward layers. This ability to model relationship efficiently is what powers modern large language models like GPT. So the whatever we've gone through here, that is nothing but the model. Here it is. Sorry, transformer. Alrighty, let's just simply keep it simple, and I think this should be enough. Alrighty, so whatever we had to go through, we've already gone through at least this particular part. Now we know what are transformers. They are the neural network architecture. They are just simply encode, decode, do what n number of things, and at the end of the day returns the result. Encoder, decoder encodes the data into tokens and all, decodes the tokens. Vectors, we already know. Embeddings, the data is embedded into vector DB and all. Positional encoding, order is also added. Semantic meaning means gets the right meaning of the data. Self attention knows or has the relationship with other words, knows about others. Softmax converts converts the logics into probabilities. So ultimately converts the result into probabilities. Multi-head attention, seeing the data from different perspectives. Temperature adds more variety, creativity. Knowledge cutoff, the limit of the data availability for a particular model. That's crazy, but okay. Tokenizations, converting the data into tokens. Vocab size, the dictionary or the vocab size a particular model has for converting the data into tokens. Okay, so these are the things that we have gone through, and now we actually have to go through some actionable stuff. Going through actionable stuff in the sense, this is the link that we actually have here. So oh well, it's too much. So ultimately what are we gonna be doing here? Tokenization.py. I think this is the part of, or yeah, this is something that we have to try in action, right? Ultimately we have to convert we have to import the token model, not model, yeah, we can call it a model or a package, and then we have to just call methods on top of this. We have to define the GPT. So ultimately we have to just simply use this package or the model. Okay, but before even that, this first part is sort of uh, we've gone through. We have the tokenizer by the Versal, and we have Attentional all you need. We have GitHub repository, that is fine, and we have the vector embedding projector as well. So okay, we don't really need to worry about this. Attentional all you need, you can just simply go through this. We can download it and just go through it. Get rid of this one, and this is nothing but the vector representation of the data. Again, it's just simply facing it and all, so let's not worry about that. Okay, so this is how the data is actually uh, stored in the data vector db and all. If I just search anything, I don't think my name is gonna be there. Okay, Vipendra is not there, so ultimately names are not there. Yeah, English words are gonna be there. Robert, as simple as that. English names are there. So yeah, but publish. Okay, so we have the words, English words mainly they are there, not the Hindi ones, but this is how the ultimately the overall vector embedding looks like. So let's just simply close this as well. And now the interesting stuff comes, that is this. We have to go through it all. We have to go through the pydantic first of all. So ultimately these are the things that I just simply once learned, and time to just simply go through it so that we can actually use all the knowledge in the project. So pydantic is nothing but it is data validation library. The way we have Zod or Joy in Node.js, the same way it just simply validates the data. So again we have quite a lot of things over here. So welcome to pydantic validation. We'll have to go through it. And regex, what is this? Let's just simply go through them. So this is the pydantic website, and what they are saying that pydantic is the most widely used data validation. As simple as that. Data validation that simply validates the data library for Python. Fast and extensible pydantic plays nicely with your interns Linux IDE brain define how the data. Okay, ultimately this is the job of the pydantic. Now how it's used and all, I'm gonna be going through first of all my notes, and we'll do the things in action, and after that we will do what? We will go through the probably this part as well. And this is the regex. So from here we can actually get the right regex to use. So regex in the sense my patterns, we can just simply search for regex. How to know? Community patterns. So we have email validation, password validation match. This you can click on email validation. This is the regex that you get to just simply validate the email. Password validation, this is the regex you get for the validating the password. So this is how this simply keeps going on. So you have many regex there, like even you have URL validation. So this is a regex for that. URL filter we have here. So ultimately, yeah, there are many regex already available that can be used. Let's talk about this VENV. This is nothing but a virtual environment that you create to write Python programs, and inside that particular virtual environment uh, you can install packages. So it's like your mini virtual environment, because if you just directly install Python programs in your local machine directly, so once you install, they're always gonna be there. So it's better to create sort of a environment, so that whenever you install something, that gets installed, but that installation is limited to that particular environment, and when you delete the environment, that is gone. So this is how this simply goes on. Again, as I said, we have to do all these things in action, so we are gonna be just simply going through this stuff. So let's see. Now this is related to Udemy. I mean, especially where I have to just simply save the stuff and all related to GenAI. And as of right now, I'm just simply gonna be creating a folder called revising or something. That should be sort of enough. We'll see exactly what we can do, and then later we'll delete this folder. What else? And that doesn't mean that we will just simply be limited to the notes. Rather, on the go, what is VENV in Python? Let's talk to the AI regarding that. So VENV, virtual environment, as said earlier, in Python is an isolated Python environment that allows comes to the node projects. So we initialize the node first of all, then only we start installing these node packages. For that thing we need npm and all. The same way we just simply do it here. So why do we need a environment? Like we have two things, right? Npm install, suppose I want to install .env, so we install it like this. So it is just simply limited to the npm environment that we created, or it is limited to the like npm project itself, and we can even install it globally .env. So this just simply gets installed globally. So when you install something globally, that is available everywhere. So that is why we create an environment, so that each project has its own environment and they just don't like conflict with each other and all. Going ahead, we have a okay, that's fine. Yeah. We have a project A that requires the Django 4.2. We have project B that requires Django 5.2. If you install packages globally, so pip install Django, only one version can exist, causing conflicts. With VENV, each project gets its own copy. So project 1 can have 4.2, project 2 can have 5.2, and there's no conflict. So this is how it just simply goes on. And without the environment, we have everything in the global everything is installed in the global environment, or globally every project shares these packages. Updating one package may break another package, but with this they have their own. How to create a virtual environment? So step 1 is to just simply navigate to that particular project. Second is create a virtual environment. So Python m probably what it is, VENV, that's the name, like that's what is this, just a sec, let me go to my notes first of all. Here it is, let me just simply have it here. So the first part is what, I hope I mentioned it earlier. VENV, my VENV. The first one tells you exactly what you wanna create. So you wanna create a virtual environment, and the second one is the name that you are just simply gonna be keeping in there or giving it. Coming back to this Python m, now we'll have to, or Python 3 m VENV. This creates VENV folder, and inside the folder again, what as we said, for the Windows we use scripts, so we will have to run this particular command. And in Mac or Linux, source VENV bin activate, because ultimately bin is for Linux and all. So ultimately this command you have to run. Again in my notes I have that as well. So coming back to this, where do I have it? This is gonna be for the Windows. Alrighty, so these are the commands ultimately. It's good to just simply reorganize your notes as well. Okay, so this is it. This is how it just simply goes. Pip install, you can upgrade pip. Pip install, upgrade pip. Pip install, by doing this you can just simply install anything. Coming back to this, we've gone through this part. Prompt, because prompt becomes venv user ubuntu, and this env prefix means venv prefix means you are now using the environment variable. Install packages, you can just simply install the packages like this. Pip install numpy, the packages are installed inside virtual environment, not globally. Check inside the packages list, so pip list, and you are gonna be getting all the packages inside that particular environment. Deactivate, so just simply write deactivate and it's gonna be deactivated. Meanwhile, let me check it in my notes as well. So this way you can just simply install. How to select an interpreter inside this, okay, we will go through it practically. And you can even freeze, so like all the versions of the packages, they are just simply, or the models, they are just simply saved in requirement.txt file. And pip install r requirements.txt, something I'll have to know more about. I forgot it, come on, but okay. To share your project's dependencies, you can just simply create a requirements.txt file, and then you can just simply share it with anyone, and another developer can install the exact same versions with okay, it is mainly for installing that. So pip install, this is for creating, this is for installing, probably in the reverse order. We'll go through it. So versions, anyway, okay, with exact versions, and to install with the same, as simple as that. Should you commit venv to get? No, instead add it to get ignore. So this is not gonna be added. Only commit the files like requirements PyProject toml if using modern Python packaging your source code. Anyone cloning the project can create their own environment, so they are gonna be just simply creating them like this. How this works, so when you activate a virtual environment, it modifies your shell's path, so the Python and pip commands point to the executable inside virtual environment. Instead of system-wide installation without activation, Python still points to the Python. So with activation, it points to venv bin Python, that is fine. Similarly to pip pointing to this. This is why packages are installed into the virtual environment rather than, so that's fine. So in short, venv creates a private Python environment for a project, ensuring that its dependencies are isolated from the other Python projects and the system-wide Python installation, that is fine. Okay, so ultimately we have gone through this. So as we have done this part, so let's do one thing, let's do it in action. So over here, what I'm gonna do, that what was the first thing anyway, mkdir, and even when it comes to revision, so we are going to be revising many things at a time. So mkdir, and this is going to be tokenization, lscd tokenization, here we are, and python m, and venv, my venv, I'm going to be naming it differently. Python mvenv, venv. M means here. What does it what does M stands for? So M flag means run a library module as a script. So instead of running a Python file directly, Python looks for the specified module and executes it. The general syntax is this: M module name in the arguments. Breaking it down, Python starts the Python interpreter. M execute a module. venv first one, the built-in venv module. venv second one, the name of the directory to create. So the Python internally does something similar to Python path to main.py python to path to python lib venv main.py venv. The first venv is the module and the second venv is the folder name. So, okay, that's the module. So this first one is the module. So why not just venv? Because venv is not a standalone executable uh, it's a python module that comes with a standard library. So the -m flag tells python find venv module installed with this python interpreter and run it. So other common examples are m start simple web server, so python m http server. So instead of writing your own server, python runs the built-in server. So install packages, python m pip install requests. So this runs the pip module using the current python interpreter. Okay, this is often preferred over just this, because if you have multiple python versions installed, python mpip guarantees that the python packages are installed for that specific python interpreter. So like both are gonna work, but this is sort of preferred. Okay, that's fine. Check python version of this pip. So python mpip, we can just simply get the version. Run module you created. Suppose you have created a module, so app suppose pip created over here, so we can just directly run that. So python looks for app main.py and just simply executes that. So in summary, python venv means use this python interpreter to run the built-in venv module and create a virtual environment in a directory named venv. M flag is useful because it ensures you are running the module with the correct python installation, avoiding issues when multiple python versions are installed. Okay, alright, it's gonna be my venv. This is fine. How to select an interpreter? Again, an interpreter needs to be selected. So Control Shift P, select interpreter, enter the interpreter path, either use direct URL or find the path manually. Creates the requirement txt file for the project, mentioning the names and versions of the packages used in the project. That is fine. Use this file. You can even import all the packages with their mentioned versions in one go, on go or one go. Alrighty, we've gone through it. Let's do it in action ultimately. Python this python not found. Did you mean python 3? So I'm using linux, so I think python 3 is actually used in here. How about here? Where is it? Let me see. Yeah, so the virtual environment was not created successfully because ensure pip is not available. On Debian Ubuntu systems, you need to install python 3 venv apt install python. You may need to use sudo command after installing python 3 venv. What should we use? Let me just directly talk to the AI regarding this. What should I use in Ubuntu, Python or python 3? On modern Ubuntu, python 3 is generally used. Why? Ubuntu intentionally keeps python 3 interpreter installed by default. Python may not exist or may be a sibling to python 3 depending on your system python version. Let me see. Not installed. python 3 is installed. So yeah, this is not even a sibling right now. Python 3 version returns python 3 recommended commands. Create a virtual python 3 is gonna be used. Activate install packages, pip install requests, python and pip, or yeah, it can be used directly. It just simply says that run this pip as a module. Notice that after reactivating the virtual environment, Python points to the Python inside the environment. So Python points Python inside the environment, that is fine. Inside the virtual environment, it's perfectly fine to use Python or pip, any one of them, to check what your system has, which Python or which Python 3 or the versions are gonna be just simply getting the job done. Which Python 3? We have user bin in Python 3. So inside this we have Python 3. Which Python? We don't really have it. Alrighty. By the way, what does this mean? What does this mean? How long has it been anyway? It's been pretty great. Let it be 1 hour, and then we'll take a short break, and then we'll continue. This error is actually quite common on Ubuntu. Let's break it down. So what happened? You ran this command. Python tried to create a virtual environment by creating my venv folder, copying the Python interpreter into it, installing pip inside the virtual environment. It failed at step number 3. What is ensure pip? Python has built-in module called ensure pip. Its job is install pip into a new Python environment. When you create a virtual environment, Python internally runs something like Python m ensure pip. So it just simply makes sure that it just simply runs this. So this installs pip inside a virtual environment. Why did it fail? Ubuntu and Debian split Python into multiple packages. By default, you may have only Python 3 installed, but venv functionality including ensure pip is a separate package. In Python this particular version, since the package isn't installed, the Python said that it is not available, which means I know how to create a virtual environment, but I don't have the component needed to install pip inside it. The fix can be the error message already tells you exactly what to install. Since you are using Python 3.1.2, update it, and then after that in sudo apt install, and this particular thing needs to be installed. Or on some Ubuntu versions, sudo apt install python 3 venv. After that just simply create it again and it will work. Okay, great. Ultimately that's the job. Coming back to this, it already tells exactly what to do. So as we have it here, so sudo apt install, sudo apt update. First of all, it's been long time since I updated this. Hopefully it's gonna be quick. I even need to upgrade this. So once I am taking a break right now, I'm just simply gonna be upgrading everything. That's gonna be a bit time taking, but okay, that's worth doing. But let's quickly create the environment, quickly run that, and then we can just simply call it. Will it take a lot of time? I'm just simply updating it, it's not upgrading. So usually update takes less time, but this is my entire system. So I'm not sure. It's not even good idea to stop it in the middle. Oh, thank you, it's all about to be done. That's great, thank God. Okay, so Python this, it still tells me that. So sudo apt install python 3.12 venv. So yeah, it's good to install them, but you should know what that actually does. Anyway, that's just simply required, so it is just simply telling us to just simply install. ls. Now let me delete everything. So alrighty, that's deleted. And now python 3 m venv my venv virtual environment. So So hopefully that virtual environment is created. And now we have bin over here. This is mainly for the Linux and Mac, and we have include, we have lib, inside that we have all the packages, lib64, we have all the packages and all. Okay, that's fine. And now let's do it really quick. We are gonna be having something called tokenizer here. So tick token is something we are gonna be using. Tick token, it's better to get the code directly from the what documentation itself. This way we will know more about that. Let's go to the this is the npm package. Well, actually tick token actually does exist for the npm package as well, so you can install it, but we have to have it for Python. So tick token.py. Is it gonna be taking a lot of time? Ultimately this is how it just simply goes. So we have to import it, but before importing it, it needs to be there, and then we can just simply go through this. So the environment is created. Once my env is created, should I create files inside my env, or just activating is enough? No, you should not create your project's files inside my-env. My-env folder is managed by Python and only contains the virtual environment, Python executable, pip install package, etc. So the correct project structure is gonna be, we have the virtual environment over here, and we are gonna be creating the files in here. Your code goes outside the environment. Typical flow is gonna be cd tokenization, Python this, my-env, source this, my-env bin activate. Then inside that's enough. You don't need to do anything else. Now we can just simply have the things in here, and it will just simply do the job. What is inside my-env? Then we have these things. These are internal files that make the virtual environment work. You generally don't open or modify them. Think of it like node modules. If you've used node.js, so yeah, let it be the way it is. Alrighty, so let's just simply go ahead. So we are gonna be creating main.py over here. So come on, touch main.py. Inside tokenization we have main.py right now, and now over here we have to import this pip install tick token, and even some info is given here exactly how it can be used. So pip, before even that, source slash my venv slash, where do we have to go, my venv bin and bin slash activate. It is saying that nothing as such exists. We just have to say my venv. Okay, we don't have to mention this slash over here, source, and then this. So right now we are getting my venv, so that particular environment is activated. ls we have these two over here. Pip list is gonna list all the packages. Right now we have only one. Pip install, I'm not sure if I will work here, tick token, because in Node.js it works. Okay, it does not work. Install tick token. You may have installed Python packages into global environment, which can cause conflicts between the packages versions. Would you like to create a virtual environment with the packages? Don't show me again. I know where I'm installing this. That's inside the virtual environment itself. So pip list. Now we have a tick token, and tick token didn't come alone. It got this requests, rejects, all these things together, that is fine. Okay, so we have done this part. Now what is the next thing? The next thing is that let's keep it side by side. What is the use of even memorizing the stuff? Coming back to this, we have to import it. Import tick token. So we are gonna be importing tick token, and now we have to have encoder is gonna be to encode this. Get encoding. So let me see. Encoder. That's gonna be tick token dot. Now I'm not getting any suggestions in here. That is why I'll have a look at this. Tick token dot encoding. Why am I not getting any suggestions? Encoding for model. And any suggestions here? Not really. I'll even work on this, how to get the suggestions over here. GPT-4040. So we have what? We have get encoding, we have encode. Okay, this is the encoder over here. So tick token encoding for model GPT this. Once we have this, then we can just simply encode the stuff. So we have the encoder. So now we have to encode what we can even print. Let me do that. Print vocab size, and that's gonna be encoder dot. The only bad thing is that we don't get any suggestions, so I have to work on that. Vocab. And now the thing is that how can I run this? So python 3 main.py if I'm not wrong. Let's see. So it is just simply returning us the vocab size around 200,000. So around 2 to the power 1, 2, 3, 4, 5. What 2 to the power? 2 multiplied by 10 to the power around 5. So, and 10 to the power 5 means what? That is less than a million. 10 to the power 6 is gonna be equivalent to a million. Okay, never mind. Okay, so this is done. And then we can have the text over here. And the cat, I will explore the documentation, but let me do it in action first of all on the mat. So we got the vocab size in the sense get encoding 0200 case, forget about that. Encode, decode, that is also fine. Encode it and then decode it there. Encoding for model. Coming back to this tick token educational. I need to know more about it. Having said that, let's come back here. And tokens are gonna be equals to what? Encoder that we actually have. First of all, we have to just make sure that we get the suggestions that we are not really getting right now. So we have to make sure that we get, and tokens are gonna be alright. Let's just simply write one more time. So these are the tokens that we actually got. Once we actually got the tokens, so those tokens should be my tokens. They're actually going to be the tokens here. And once we have the my tokens decoded, that's going to be equals to encoder dot. I'm just simply having them side by side, but very soon I'll explore the documentation. Print decoded. Alrighty, this seems to be done. So let me see. So first of all, we had these tokens, and then the token actually got decoded. Then we got this decoded value. So we can create the tokens, we can decode the value, and this is how it just simply goes on. But the documentation that we actually got here, that's not the best one. So now tick token tutorial, probably this. This is just a blog, but they are providing everything here. So first of all, they are just simply saying that you have to install it. Once that is actually installed, then after that you can create the token, you can encode the data. Once the data is actually encoded, after that you can even decode the data like this. Then you can get the length of the tokens as well. So yeah, this is how you can just simply go on. The interesting part is that this I'd like to go through. Encoding models in token determine the rules for breaking down text into tokens. These models are crucial as they define the text is split and encoded, in impacting the efficiency and accuracy of the language processing tasks. Different OpenAI models use different encoding. Tick token provides 3 encoding models optimized for different use cases. 0 to 100k base encoding for the newest chat GPT-4 mini model. Then this is what models, they are the models. Tick token provides 3 encoding models to optimized or models optimized for different use cases. So this is the encoding for the excuse me, newest GPT-4 mini model. Then this, then this, then this. Ultimately all of these models are available with OpenAI's API. Notice that API gives access to many more models than I have listed here. Fortunately, that tick token library provides an easy way to check which encoding should be used with the which model. Okay, that's fine. I'd like to have this nclg or not clg print enc is gonna be equals to enc. Let me run it, and it gives us the encoding 200 base. So it gives us about that particular encoding exactly which one being used here. Alrighty, as we just simply dig deeper, we are gonna be knowing more about this stuff. But the good thing is that overall we have the idea exactly how it's working. So that is fine as well. This is the code that runs for that. So we have encoding for model, we have encoding name for model, and so on and so forth. We have this stuff. Anyway, that was it for now, and this part we've already gone through, and probably the same code I would have here as well. So that's a lot to go through. It's just the beginning, but overall the last thing that I can actually do over here, that is pip freeze into requirements.txt. So what will happen, that it's actually gonna create a requirement.txt file in which I have the exact versions listed over here of all the packages that we actually have in here. And later on what I can actually do, that pip install our requirements.txt. so it's just simply gonna be installing them. Now the only thing that I need to know, this is the last thing, that I think R stands for recursive over here, but I'm not sure. Flag R mean here. So let's just simply go through this last part. And flag M means we already know exactly what it means here. So but we didn't really keep it here, that's crazy. Yeah, that's right. R flag pip install R so means requirements. R stands for requirements. So R flag in this means requirement. Okay, that's it. Tells pip don't install a package whose name is who don't install a package whose name is requirements.txt. Instead open this file and read the file list of the packages inside it and install the one. Okay, so this just simply references to the requirements. So at the end of the day, over here M means run the module, mentioned module. Over here DENV, and when it comes to install, and over here -r means requirements. That simply means if I just simply have hyphen requirements, well, that doesn't work. Requirements, I thought it would. If you run pip install request, it is gonna be just simply pip installs the single package or requirements.txt, so it will make sure that it just simply opens this file and just simply installs everything. Alright, that was it as of right now. I think if I just simply have the requirement over here, it should ideally be working, and yeah, it does work. Either you have -r flag or hyphen requirement flag, both are gonna be working in there. And coming back to this should be requirement. So both of them are they have the same meaning. So that was it as of right now. Good to have some space in between. Alrighty, this is the only one thing that is remaining. Like, we don't really have any. Control Shift P. Let me do it. That is gonna be interpreter. Select an interpreter. Then Python bin interpreter path. Control Shift P, select interpreter. So this is the global one we can select, but once the interpreter is done, am I gonna be getting decoded what encoder dot? Am I getting suggestions? What is the use of the interpreter? It gives us the suggestions, it is not giving us. So let me enter the interpreter path, create virtual environment. Not this one here, that's bad. Virtual environment was already created. Create interpreter path. Find tokenizer my BNB bin usually it is bin Python, right? So, or just a Python 3, I'm not sure. Encoder dot, okay, now we are getting there. So we have to just go to bin. Interesting. Workspace. So we have to just simply come to this particular part. Python is automatically gonna be selected. Global is Python 3, but here we have Python, right? Python main.py. As expected. What expected? Yeah, as expected. Can we run Python 3 main.py? No. Okay, both work. Which Python? Which Python 3? Okay, both work. I mean, both exist in here. But at the end of the day, we have to have the encoder for the virtual environment. So we'll have to make sure that the encoder actually references to the virtual environment, so that whenever we just write anything, right, take token dot. So at the end of the day, we have encoding for model, encoding name for model. So this gets easier to write the code. Alrighty, that was it. I'm gonna be catching up soon. Until then, bye bye, take care.